Hello and welcome to this podcast for Electropages. I'm your host, Robin Mitchell. Today we're joined by Sfera Labs once again, who we have seen on this show many times, who do some fantastic stuff with industrial systems and Raspberry Pis. And before we go into the details of what you would like to show today, please tell the audience who you are, what you do, and what you like to do in your free time.
Okay, cool. Hi, Robin. Thanks for having me today.
Again.
What do? I like to design things, whether it's software or hardware. Actually, originally, I am an electronic engineer. Then I worked for almost 30 years in mission critical infrastructure software. And then about 10 years ago, we moved back to hardware with Sfera Labs. So we are on both sides of this. And you asked about my spare time. Well, that's spent on many different things. I am an amateur radio operator.
Yes, I remember
those guys.
Yes.
Those guys that in the age of internet and artificial intelligence, they do...
Just a quick question, what's your call sign? What's your call sign?
IK2TYL, India Kilo 2 Tango Yankee Lima. Thanks. And I do like CW, Morse code, radio and stuff like that. That brings me back a little bit in time. Although even these things are done in a very modern ways today. Then I sail sailboats and I fly gliders and airplanes in general, and a few other things, but these are mostly my hobbies.
And if I remember correctly, your wife also runs the company with you as well at Sfera Labs.
That's right.
And she also has
and we share many of these.
I was about to say, you guys are you're both pilots, aren't you? Technically, you're both pilots. Yeah.
She was even forced to get the amateur radio license.
Forced to.
Then,
I love that.
Well, I don't know if you want to talk about this, but
go for it.
Basically, we got married. We got married back in 1990, and at the time you had to go here in Italy to get the license. You have to go through an exam that was basically handled about once a year at the Ministry of Telecommunications. And so we got married. We went out on our trip after the marriage, and they called us while we were on our honeymoon trip, okay? And I tried to negotiate if we could maybe just keep it for a couple of days to do the exam for the amateur radio license. I didn't make it. I was not convincing enough. And so I had to wait like one more year to get the license because of this inconvenience of getting married while we were supposed to take the exam.
Do you know what? You don't get stories like that often, honestly. That is a brilliant story. You should honestly put some of this into a book, because I do believe people genuinely find this interesting. Because, it's just like the thought of both of you as a pair, starting a company, you're both in the same interest. It's a really amazing story, and it always warms my heart every time I hear it. And honestly, it's absolutely fantastic. But yeah, it's great to have you back here again. And as I understand it, you've got some great new stuff to show us today, because I believe it's a bit more of a show and tell this time. Yeah.
Well, basically, we back in Nuremberg a couple of months ago, in Germany at Embedded World 2026, we announced 2 new products and many other things like new expansion boards for the Strato Pi Max line and stuff like that. But then 2 completely new products, which are actually completely new, but they also follow, let's say, a path that from like previous and still existing other products. These 2 products that we announced are called Iono Pi version 3. And the other one is called Strato Pi Plus. Just to put the names into context, the Iono line for us is basically related to I/O modules, so input-output modules, normally based on Raspberry Pi computing cores or Raspberry Pi microcontrollers. The Strato line is basically edge servers, all based on Raspberry Pi computing cores.
So to make sure that I remember correctly, your main product line tends to be things like programmable logic controllers based around Pis, which you enclose your own circuits and I/O systems, and that way you have like industrial controllers. That's
exactly.
I believe it.
Exactly.
Yeah.
Exactly. So we have these two lines to make things clear, in the sense that the Iono products have specific I/O lines, like digital and analog input and output lines typically, while the Strato line is more about pure edge computing with interfaces, of course. Then, of course, there is not a, let's say, a clear cut between the two, but these are the two different lines. And the funny names, Strato and Iono, come from the fact that the company name is Sfera Labs. So Sfera is sphere in English. And so we have stratosphere and ionosphere and so on. That's where the names come from.
And I'm guessing I'm guessing in terms of the ionosphere and the stratosphere, the closer you get to Earth, the closer it is to the metal kind of thing.
Exactly. Yeah. That's now So we have the strato, iono, then we have exo, and there are a couple of more layers in the atmosphere.
And then the outer space version.
We can expand, yes.
Magneto.
Yeah, exactly. I don't know if these names are nice or not. We like them, but we've never been very good at names. I must say.
Oh no, I've heard far worse names. Trust me, far worse.
Anyways, okay. So now today, if you like, we can talk about just one product, because talking of many, it would be a nightmare and too confusing.
Well, I think the best thing would be to just sort of like you just decide which one do you think you'd like to show today. But before we do, I actually have a quick question. It's a bit off topic, but kind of not, because I'm kind of curious about this one thing. So your devices are all based on Raspberry Pis and those pre-compute modules. With the ongoing RAM crisis, I'm kind of curious if you are facing supply chain issues or how you're navigating that, because if you try and buy a Raspberry Pi today, they are absurdly expensive because the RAM chips just aren't available anymore. So I'm kind of curious how you guys are handling that.
Yeah, well, basically we are not facing supply chain disruptions in the sense that we don't have access to the products. It's like the problem of fuel for your car. It's not that there isn't. It's just that it costs.
It just costs more, and so you can still get product. You can still get the capacity.
Absolutely.
It just costs more at this point.
It just costs a lot more. The issue with that, it's not something that can be easily said. Well, it just costs a little bit more because it's a lot more. Even Raspberry, if you know them. You know how hard they try to contain and possibly absorb directly themselves these kind of fluctuations in costs, and try as much as they can not to pass that to their customers.
I've literally seen some Pis go up by an extra $100, almost double in price, and it's not even the base components. It's just that few RAM chips, and it's absolutely bizarre how this price is just shot out of nowhere. But again, they try not to. They try not to, but they are forced. They have to. They can't pay for your RAM. They have to
Exactly. For example, there was this announcement on April 1st. Great day for an announcement, of course. By Webben, when they had to basically jump with all the prices, particularly for the old versions with more like 8, 16, and even 4 gigabytes of RAM, and they skyrocketed. The other day I was joking that for home, like 1 month and a half, 2 months ago, I bought 2 brand new Raspberry Pi 500, and the Raspberry Pi with the keyboard embedded in the keyboard, just for home, just to put it in the kitchen and whatever. And I got those with 16 gigabytes of memory. Oh. And I said, well, that was one of my best financial investments in my life.
You should sell them.
Because now they're almost double the price. But no, anyways, we don't see a shortage, but we see an issue.
It's just the price increase.
With those. And we don't know when this is going to end. I mean, in the electronics industry, prices go up, and they also go down by a lot. It has happened before. It will happen again, even with that. So it's not going to be like that. Prices will stay
indefinitely high. Yeah,
forever.
They will come down. But I think there's a bit of a misconception, I think, that people currently have, which is that right now the vast majority of RAM chips have been purchased, or the capacity to make them has been purchased by AI companies. And people think that when the AI bubble pops, suddenly there'll be tons of RAM chips on the market that'll be cheap. But the problem is the kind of RAM chips that they're making are not the same ones that you would put on a Raspberry Pi. They're high bandwidth memory ones. So unfortunately, even if it pops, the RAM would still be expensive because it's the wrong kind of RAM. So you still can't get your consumer stuff. So the price would still stay high until the foundries can put out enough chips on the wafers to meet the supply. So it could be like 5 years before we even see prices stabilize in that market. And like you say, prices do vary all the time. But it's incredible how this one market has just absolutely dominated the price for everybody else. Industrial, automotive, consumer, it doesn't matter. All of those markets are massively affected. But like you said, it's the price, not the availability.
Yeah, and there is a problem here, even about handling the price. Like, the problem is that in our specific case, we do not develop and sell consumer products. So if I sell a consumer product, of course, I would be in big trouble anyways. But at least like today, I would be selling this at a certain cost, and if in 3 weeks I have to raise the price, I do that. Then the market reacts. Easy. End of the story. Well, not easy, but at least there is a direct relationship and something that's easy to understand. Problem is that when, let's say, the whole product life cycle of what we do is extremely long. Like today we are introducing this product, Strato Pi Plus. Fine. What happens next? Someone will see this product. They will start looking at it. They will get a few samples. They will start developing, or at least porting, integrating their application on this. That will become, at the end of their own development process, a finished product, and they will finally have to market that. Of course, when someone comes to us and they start the process, they come to us and say, okay, well, now we need to define the economics of the projects. And so they need to budget the costs of the parts for their product. Okay? Today, it's basically totally impossible to predict what the cost will be of a product anytime in the future. And many customers come to us and say, well, we would like to have like a quotation for this product to buy, 10,000 units over the next 2 years. What's the price for that? What do you think we can answer?
If you buy them, if you buy them tomorrow, we can give you a price, but you have to buy all of them tomorrow.
Exactly, all tomorrow. Yeah. Exactly. So the issue, again, absolutely, so far, not about availability, but about handling how to manage, let's say, this total uncertainty about costs.
And I suspect that in your case, because you're designing industrial products and industrial systems, the guarantees and the reliability that you give isn't the price; it's the fact that it will be available for 2 to 3 to 5 years, and it will still be
that's more important.
And that is more important, because if you've got a production line, you don't really care if a controller's gone up by $50. What you care about is that you can still buy it, it's still supported, and it can be fixed. And so, and that's what these companies they don't care about the price; they care about that security net, that guarantee.
Yes.
And
that's another important thing. Again, in some cases it's still a problem, because if like one of our, let's say, customers intends to develop an application based on this that is, let's say, that doesn't have such a wide margin compared to where basically the cost of this is still a relevant part of the overall cost, then they will be in trouble anyways, because their end product, let's say, product will be affected by these fluctuations. Of course, in other cases where you have one of these inside a super large piece of equipment, maybe costing millions, then
not going to make a
availability is the only concern. It's not concerned about a few €100.
And while I don't know the size and the breadth of your customer base, I would suspect that pricing to them is going to be less of a concern. You are going to have some customers where it is a concern, but I suspect that most of them are kind of like, oh, is it an extra $50? Okay, that's not a big deal. We'll do it anyway. Because, like you say, we're building a $10 million piece of equipment and we just need 5 of those things in that system. So it kind of makes sense that their concerns are just different.
Sure. Yeah, no one's happy anyways, but availability is the real deal breaker if it happens.
So moving on to the product of concern here, the Stratosphere. No, Stratosphere, I apologize. The Strato, what's it called again?
Strato Pi Plus.
Right. Stratosphere was named after the Stratosphere.
It was named in the Stratosphere.
So tell us a bit about this product and what is different compared to the other products that you've released.
Yeah. Well, it's quite different and quite advanced, actually. Now, I show you basically the open package. I can even try to destroy it, disassemble it. What you see here is a normal Raspberry Pi 5, okay?
Very, very quickly, I had to...
Not the compute module.
Very quickly, you mentioned about your name, you claimed that your names were bad for your products. I was just thinking, if it's Italian and it's intelligent, you should have called it the Da Vinci or something.
Well, yeah. There is an airport that is Da Vinci. There are museums,
fair enough. Yeah,
things.
Michelangelo.
Yeah, but my son's name is Leonardo, by the way.
Oh, perfect.
So we got close.
You got close.
So the Strato Pi Plus, first of all, is based not on the compute module, on the Raspberry Pi compute module, but on the I don't know how to call it. It was once called Model B, so Raspberry Pi 3, 4, whatever, Model B. Now it's called Raspberry Pi 4, Model B, or Raspberry Pi 5 without anything else. But this is, if I can say, the normal Raspberry Pi that everyone knows. The one with the Ethernet ports, the USB ports, and blah, blah. The same thing that is also used for hobbyists and whatever. But, so not the compute module. While many of the other products in our product lines are based on the compute module, this one is based on the normal Raspberry Pi. We have other products. That's not the first time we do that. Of course, there is a huge difference between developing a product based on Raspberry Pi, whether it is based on compute module or the normal Raspberry Pi. This has the ports basically already integrated. That means we have less flexibility. We are subject to the, let's say, changes that Raspberry Pi does when they introduce a new version and stuff like that. And we have, of course, a very constrained to the specific form factor of the board. We cannot do much about that. We also have a lot less interfaces at the GPIO connector level compared to what we have in the compute module. Okay.
Just a quick question, because I'm kind of curious about this, because how many extra GPIO do you get when you use the module version?
Oh, well, it's not the GPIO in terms of actual GPIO for basic IO lines, but what you get is access to things that you don't get at all here. It's not about the number. It's about like PCI Express lanes, USB 3 lanes, HDMI. So all the basically besides the GPIO, all the high-speed stuff
you get so much more, you get much more flexibility, and you can build it in any way you need it effectively.
And so you can bring that part of the interfaces out and shape them, arrange them the way you want. That's what you do with the compute module. So you have more flexibility, both in terms of the electronic design and the mechanical design.
And then there's the repairability, because you can actually replace the modules if the new one comes out with more RAM, and you can say, well, here's a new version with more capability.
And because we control all the peripherals, all the interfacing, all the everything around the compute module, we can basically keep our design more stable over time compared to something that's based on the normal Raspberry Pi. The downside of that is that typically every product based on the compute module costs more than the equivalent thing, let's say here, because here you have a lot of stuff that is also quite expensive, all the interfaces and whatever that is built in. So, but if you use the normal Raspberry Pi and you work well with the GPIO and what you have, like the great advantage of the Raspberry Pi 5 is that they now have at least the PCI Express connector here. So you can have a very, very high speed interface available that you did not have with Raspberry Pi 4. But let's say the good thing, if you can work with that, with this format, is that the overall product will likely be cheaper than the exact same functional equivalent product based on the compute module. So this product, we don't like to stay just in one camp. There are other companies who only develop products based on the compute module or on the normal Raspberry Pi. We try to have both, because I think there are, let's say, good points on both camps.
Well, it's just flexibility for the customer at the end of the day.
And it's flexibility for customers. Okay, exactly. So now what we have here is basically this is the inside of the product. So it's basically a normal Raspberry Pi, and this is basically what we do. This is something. It's like a shield, a hat. It sits on top of the Raspberry Pi, connects via the GPIO connector, and provides features to the Raspberry Pi 5 or Raspberry Pi 4 below. This is compatible. This specific product, Strato Pi Plus, is compatible with both Raspberry Pi 4 and Raspberry Pi 5. Now, this is a quite, let's say, dense. It's hard to show on camera, but it's a very dense product. What it does is basically an edge server solution. So it's a Raspberry Pi intended to be used as an edge computer, where you also need a lot of serial connectivity to, let's say, field devices, field systems. So this one has, Strato Pi Plus has basically 4 RS485 serial ports, each one individually isolated. And that's a big deal, because full galvanic isolation takes a lot of space and adds significant cost to the product. these ports are also very heavily protected from surges, spikes, and all this.
Well, it's an industrial environment, so it's going to be the noisiest, most dangerous stuff you could possibly have.
And that's also why the multiple serial ports are all individually isolated. Because, like, you may have one port going to a piece of equipment, another port going to another one, and you don't want to have basically the ground references in common between these. And besides the 4 RS-485 ports, it has a CAN bus port that supports both CAN 2.0 and CAN FD. CAN FD is the flexible data rate conversion at very high speed. And that's all in a pretty compact design, if you think. This is basically 4 RS-485 ports plus CAN in this unit.
Well, it's four RS-485s with galvanic isolation in that small size, and I think that's really kind of like the key point, because like you say, anyone can make a small RS-485 transceiver, but making it isolated. That is where, because that's when magnetics come involved. That's when you have to start trying to filter signals, and then you've got the protection circuits, and all the protection, and they're bulky. They're bulky circuits. And then you're just trying to show 4 of them and then not have them interfere.
If you look around, it's not small stuff.
It's not. Actually, I'm curious. Is that a massive lithium titanate capacitor, or is that just a huge capacitor?
No, it's just a normal. It's a pure electrolytic capacitor. It's just very big.
I've never seen one that big before.
But
not SMD one.
No, the problem is that this thing works up to 50 volts nominal and 60 volts maximum power supply. So these capacitors is basically the input capacitor of the regulator stage, and it is basically rated at I don't remember if it's 125 volts or 100.
It's going to be at least double what you're putting.
So it's big. Yes, it's big and basically very high rate in terms of voltage. That's why it is so big. And that's another thing. The fact that you have a small device like this that can be powered with typically 48 volts battery, DC batteries rails that you use in telco systems or in energy storage.
And then that means you don't need it. And then you don't need a second power supply to try and bring down the first one to a safer volt. So you go straight in from the main system bus into the device.
Exactly.
And it's handled.
Exactly. Yeah. Then then it has a number of other features. I don't want to bother you about this, but
please do.
No. There is one feature that is kind of hidden, unfortunately, because there is another board here.
I can see quite a lot of things sandwiched together.
Yeah, this is a sandwich in this case. Actually, this one can be detached. I'm not going to do that now. But the interesting thing is that we said it's based on Raspberry Pi 5. Fine. But here there is also an RP2354B microcontroller from Raspberry. So it's both, let's say, a high-performance computing core and a high-performance microcontroller core. Okay, this RP2354 MCU here is not just used for, let's say, internal housekeeping of these, like watchdogs, all the, let's say, power management and stuff like that. But it can actually be used by end users, by our customers, to develop their own microcontroller code to run on this MCU here. And the MCU has access to all the serial ports and the CAN bus, basically in parallel to the Raspberry Pi computer board itself. So this adds a lot of flexibility in the way you can design things. Because, for example, let's say that for CAN bus, you are concerned about like timing issues and the fact that you want to be super responsive on the CAN bus and you don't want to let's say, pay the price of a high-performance computing architecture with its own, let's say, latencies and stuff like that.
I was about to say, because I think people sometimes not realize that something a very high performance PC, computer, whatever it is, they're very good in terms of like raw compute, but when it comes to I/O latency, they can be terrible, and that's simply because like kernels can have like 1 millisecond waits in between processes. So you could have like a billion signals come in, you have no ideas come in until the 1 millisecond slot in your task comes up, and you go, oh. Yes. That was a millisecond. That's like 1,000 microseconds ago, and you already missed all of that. But in that 1 millisecond slot, you can do loads of stuff. But it's that inconsistency of the inability to act quickly.
Exactly. And here, basically, on the other side, if you handle I/O on a high performance computing core, things are easier. In life, okay, not about timing, but about, let's say, features and
coding's easier, like you say.
So here we basically have both things combined. If you don't have timing issues, you can nicely work all your interface logic of RS-485 and CAN bus directly from the Raspberry Pi. Nice and easy.
Well, the kind of application that comes to my mind would be like, since they both work in parallel, I guess that means that both can receive the serial data at the same time and read it independently, which means that, let's say you have like an industrial system that has like a very key safety feature. Let's say something like something very precise, like a CNC milling system, or maybe like a crystal growing system where you've got to control the temperature flow. The Pi is doing the job of taking the values, reading it, making big overall decisions, sending you the data to your dashboard. But the smaller RP20, it's not 2040, it's a
2354 is the largest one of the latest version of the RP microcontroller.
And it's also the one that actually added security as well, because they had a problem with the 2040 that had no security. This one does.
The 2040 doesn't. The 2354 has secure boot and all these things.
But in that situation, then the RP microcontroller would be the thing that then looks at the data in real time and goes, if there's a sudden change and I need to make a microsecond response, it can do that while the Pi doesn't have to be involved.
Exactly. Yeah, exactly. So you can do both things. As you said, it's basically the ports are totally paralleled. So you can handle all the traffic from either the Raspberry Pi or the RP, or even both, if that makes sense for the specific use case. That's very interesting. You could, like, for example, you could handle all the CAN traffic from the RP and only have a higher level interface, a higher level API between the RP microcontroller and the Raspberry Pi.
And that's where the RP2040, sorry, not the RP20, I keep calling it the RP2040 because the one I'm really most useful. It's the 2354.
Let's say RP.
That's the big one, the new secure chip. In that case, like you say, it can store all the messages that respond as needed and then send that packaged message back to the Raspberry Pi as needed.
That's right. Yeah, exactly. And that way you handle the CAN traffic or the RS-485 traffic basically in real time fashion, and only leave the Raspberry Pi for the high level work. So that's a very, very interesting feature, and it can be really, really valuable. The other feature is what we have here in the back. That's basically the sandwiched board that sits on the bottom side together with the fan that blows air directly over the CPU. But here, talking about memory, here we have an SSD. This, of course, will only work with Raspberry Pi 5, not with Raspberry Pi 4. The SSD connects to the Raspberry Pi through the PCI Express connector here. So we can add the SSD storage. Yes, I know these days the cost of that is a problem. But anyways, if you need that, the SSD is like 10, 20, 50 times faster than a micro SD in practical cases.
It'll be 20 times faster, but now you're going to get 20 times less the storage for the same price.
So yeah, that's minor detail, but anyways, here we have the ability to also install the SSD here, and there is another interesting thing, which is that the RP2354 controls the SSD power stage. So what it can do, it can decide to turn the SSD on or off. Okay? Why would you want to turn it off? One reason could be that if you have the SSD, normally you have the SSD and then you boot from the SSD. You boot the Raspberry Pi from the SSD. That's all. It's faster, it's better, whatever. But if you also install the micro SD card, the normal micro SD card, then you set the Raspberry Pi to boot first from the SSD and then from the micro SD, so that if the SSD is available, it boots from the SSD. But if the SSD is not available, it boots from the micro SD here. Okay. This way, basically, you have sort of an alternative boot storage, boot and file system storage, completely separate from the SSD, running on the micro SD. So let's say, for example, the SSD fails, the watchdog that's running on the RP microcontroller will see that the Raspberry Pi is not working anymore. It will try to restart, it will power off everything, power it again, and if it keeps failing, it will decide to shut off the SSD so that it reverts booting from the micro SD card instead.
A quick question about that. Does the RP chip have the ability to reboot the main Raspberry Pi board?
Oh, it can basically power it off completely.
So both the SSD and the Pi board. So that's interesting because this kind of comes back to that thing where you mentioned about them both having access to the RS485 ports and the CAN bus, which means that you could have like a safety watchdog system whereby if a certain event occurs, let's say like it detects an error message on a CAN bus, it could actually reboot the Pi and then switch over to the SD card, which could then have a different type of operating system designed to handle really weird edge cases where it shuts down a whole system. So that's very unusual. That's very interesting. Very interesting.
Well, it's also interesting. I didn't mention that, like in like low power applications where you want to save power, like you might think of like a system for monitoring, environmental data with lots of external sensors based on RS485 or CAN, that's powered on batteries, charged by a solar panel living on top of a mountain. Okay, at night you may want to, let's say, shut off things that you don't need, and one of the, let's say, heavy weights in terms of load is indeed the Raspberry Pi computer. You may program the RP microcontroller to shut the Raspberry Pi, to power down the Raspberry Pi, but keep working on its own and keep the serial ports running, do its own stuff, like, I don't know, collecting temperature data from a sensor, storing it locally, and then when the Raspberry Pi turns on again, maybe once an hour or the next morning, it will flash the data upstream to the Raspberry Pi, and the Raspberry Pi will do its own things. Basically, the RP2354 here is really the let's say the owner of the whole system.
Which is funny because it's usually the other way around.
Yeah, you can. You can also, like, power management here is super important. So you can also power down other things. Like, for example, you want to keep the RP going, but you want to keep to power down even the serial ports. You can do that to conserve even more power. So it's super flexible. And the other thing about going back to the SSD with in combination with the micro SD boot sequence and failover, we can say, it's not only about failover. Let's say that you have these installed in a very, very remote place. Everything is running on the SSD, running fine. Then in like 10 years from now, you decide that you need to install to completely reflash the SSD, not just the partition. Of course, you can say, well, I keep the SSD cut in two, and half of that is for like partition A, then you have partition B, and you can swap the partitions. But let's say that one day you have to flash it all over, okay? Let's say bare metal level, byte by byte, like when you initially flash, including the boot sector, the boot partition of that, of the SSD. If the SSD is the only way for you to boot, there is no way to do that while it's up and running. You could, again, have your software ready on the micro SD so that it can flash from, it can boot from the micro SD, then access the SSD once the Raspberry Pi has been restarted with the micro SD. The SSD is powered up again, and so the Raspberry Pi sees the SSD, but it has not done the boot from the SSD.
Well, it makes it like a boot. It makes the micro SD card a bootloader.
Yeah. Now you can reflash the SSD, turn everything off again, and restart with the SSD on. And in that case, again, the RP keeps the leading role of that. And if something goes wrong, the SSD, the system doesn't restart properly from the SSD, it shuts off again and reverts back to the micro SD card. So you really have, like, again, I say, like you're having someone in the field with a micro SD in his hand, ready to
put it in, put it out,
pull in and out from the Raspberry Pi until that thing works. That's an interesting feature.
And it doesn't just have to be a remote place on the top of a mountain. It could be buried deep inside a huge piece of machinery that would be too inconvenient to open.
Very
up.
inconvenient. Yeah.
So you literally could just go, right, okay, new firmware update, reboot, does the reboot, goes to the micro SD card, changes the SSD, and then flips back over. And it's funny that you mention it because it sounds very simple when you say it like that, and it kind of makes me wonder why we don't see more of those kind of systems anyway. Because for me, that absolutely screams like reliability to the point where you've always got two copies or two different versions of an operating system. You can always boot into at least one of them, which means you can always access your system. Yeah.
And we had, going back to our original comments about the difference between the normal Raspberry Pi and the compute module, we have the exact same features related to failover, redundancy, flexibility, and whatever on the products based on the compute module. Like Strato Pi Max has exactly the same features, Iono Pi Max has the same features, but Strato Pi CM and CM Duo, all these products are based on the compute module. And there, because we control everything around, it's straightforward and easier to do that. We didn't have anything like that on a product based on the Raspberry Pi 4 or 5, and now this one basically offers this kind of let's say extra flexibility features and reliability, and we're happy that we can also make this happen on this form factor with the normal Raspberry Pi, rather than having to jump to the obviously more expensive platforms that are based on the compute module. That's an interesting thing. And the Raspberry Pi 5 that offers the PCIe Express bus, which is of course required in this case to interface the SSD, is of course key to make this happen in this case. But again, this is also compatible with Raspberry Pi 4. With Raspberry Pi 4, you don't get
the PCI Express, and that's the only difference. So moving forward with this new product, well, we've already talked about some reliability applications. What would you say that you are most looking forward to seeing it being deployed in? What would you like to see this be used in?
Well, it's just like all of our other products. We don't have a specific market in that we target because we don't develop applications. We just develop the platform, the hardware platform. Then our customers develop their own solutions, their own products based on this. So what we try to do is to offer the greatest possible flexibility. We try to not be in their way. So we don't want to force customers to use our software, our libraries.
Imagine if you bought one of these and goes, "Oh, you need a license to use this." You're like, "Oh God."
Yeah. We offer we have a very flexible platform. We offer some kernel modules, the microcontroller code, and whatever. But this is all open source.
It's all optional as well.
And it's optional because you can you can develop your own code for everything from scratch. The whole, let's say, hardware platform is completely specified so that you can forget about everything we do and develop your own stuff from the ground up. Also considering that the RP microcontroller, the RP2354B here, can be programmed and debugged directly by the Raspberry Pi that sits underneath here. You don't need to, let's say, connect an external cable or JTAG programmer, whatever. It's the Raspberry Pi uses the SWIO lines for debugging and programming directly. So you can basically reflash the microcontroller in field. The system is designed so that if you reset the microcontroller, so the Raspberry Pi can reset the microcontroller and everything keeps running. Of course, while the microcontroller is reset, it doesn't offer the protection, watchdog features, whatever, but everything else stays up so that you can actually program, even debug the RP microcontroller in field if you need to. So that's what we have. It's a very flexible platform. Then our customers, they do all sorts of things with these. We have these things widely used in energy storage solutions, agriculture, maritime applications like on board ships, environmental monitoring, industrial control, building automation, you name it. There is not a single specific market that we're targeting. We are targeting flexibility and the idea of having a very developers-friendly platform available for people who have ideas on how to develop products for their own markets. That's the point. But yeah, indeed, basically, the Raspberry Pi has found a huge number of opportunities and in basically everywhere in the industrial world. You cannot say, well, the Raspberry Pi is specifically used in this or that world. It's basically everywhere. You find it.
That is what makes the Raspberry Pi such a fantastic product. And in this case, it's helped to empower your products by giving customers that flexibility in whatever they want to target.
Yes.
But sadly, we are now approaching the end of the podcast, and I've only got one more question for you. For the audience who are watching this video, if they want to get involved with Sfera Labs solutions, what would you recommend that they do?
Oh, they get in touch.
Get in touch.
Very simple. Because of what we said about our customers, we basically have a one-to-one relationship with each one of our customers. Because our customers are developers, so they don't just come to us, buy a product, and forget. They always want to know more. They want to learn more. They want to understand how they can use the products at their best, or they may need custom features that we don't have in the standard products, and that's also what we do. So basically, we don't sell really. I mean, we do sell products. Let's say shelf products. You can go to Mouser, DigiKey, our website, and go buy the product. But normally, the relationship with our customers is much more, let's say, personal and friendly. In a sense, we really like to help them, and it's very interesting for us also to be part of a lot of honestly great projects that these people do, which are amazing. And the fact that the Raspberry Pi has been absolutely key to that, because it's both an extremely popular platform, so everyone knows how to develop on that. So it's again very friendly for the developers, and also the fact that they're really struggling, been struggling basically all the time of all these years to keep their products available, because as we said at the beginning, availability is everything. And they really, I think, honestly, after so many years, it's not about making promises, but they have delivered on that. You can still buy. You don't find them on consumer platforms and whatever, but you can industrially you can still access very old versions of all the Raspberry Pis that have been developed, because there are many customers that when they start developing something on a specific product, then they keep their product running for 10, 15, 20 years, and they don't want to change. Raspberry Pi, in my opinion, they have done a great job on that, and the reason why we develop most of our products on Raspberry Pi is really about that more than anything else.
Absolutely fantastic. Thank you ever so much for taking the time to be here today.
Thank you very much. It was great to be here with you today.
Absolutely.
Bye.
And we'll have you here again for the next product, the one you couldn't talk about.
Thank you very much.
The Ion.
Bye-bye.
Thank you. Bye-bye.
Thank you.